So we left off doing multiplication of rational expressions. So now let's talk about dividing. It's on the same train of thought. Let's start off something basic because I think some people forget one important thing. When it comes to division of just fractions, and this is not really a rational expression because notice that we don't have any variables. It's just basically all constants or just a regular fraction. You got to remember when it comes to division that you're not allowed to divide by fractions. Okay? Every time that you have division, when you do this by hand, we always changed it to multiplication and we did the reciprocal. So you got to remember that. Anytime that you see division, I don't want you to start factoring out the four corners or anything like that, or start saying, oh, I know that 40 and 18 you can go into by 2, or 60 and 72 you can do it by 12 or anything. You gotta remember that when it's division, you have to do something called copy, change, flip. We're not allowed to divide by fractions. When you put it in your calculator, it secretly does that. It changes it to multiplication and does the reciprocal. So what does copy, change, flip mean? Well, copy just means take whatever the first fraction is and just rewrite it. You're not doing anything to it. Just copying it the way it was. Change means that we're no longer dealing with a division symbol. It's going to change to the multiplication symbol. And then flip, it's just a fancy way of saying reciprocal. Okay? Reciprocal means just flip the fraction upside down. What was on top needs to flip down to the bottom. What was at the bottom, the denominator, comes to the top, the numerator. Once you do copy, change, flip, now you see that it's already written as a multiplication problem. When it's a multiplication problem, we just spent a good chunk of time dealing with these problems. Remember, you have your four corners. Now that it's multiplication, now you can do the factoring completely. We couldn't do it here because it was division, but now it's multiplication. Do your four corners. This is a monomial. This is just a plain constant number, so you know you're going to do a tree diagram. And most people know that's going to be 2, 2, 2, and a 5. 72, again, if you don't know it, do a tree diagram. 8 times 9. 8 is 2 and 4. 4 is 2 and 2. 9 is 3 and 3. And so remember, I'm just trying to get all prime numbers. Remember, I didn't stop at 8 or 9 or 4 because you can still break them down to what are called composites. So we get 3 2's and 2 3's. Next corner, 18. Most of you could do that in your head, but in case you can't, 2 times 9. 9 you can break down as 3 and 3. And then 60. Probably 6 times 10 for most of you. 2 times 3. 2 and a 5. And then I just put it in order. Once you factor out each of the four corners, remember, then we do the big super fraction bar. And then you can cancel out any monomial factor on top that matches a monomial factor at the bottom. Doesn't matter if they're exactly on top of each other or if they're diagonal of each other, as long as it's one on top was one on the bottom. 5 and a 5, 3 and a 3, 3 and a 3, 2 and a 2. And then we told you, if there's nothing left on top, there's always an understood 1. Do not leave it blank. And then what's left on the bottom, we can circle this 2 and this 3, so we get the 6. So this divided by this is the same thing as 1/6. Or this multiplied by 1860 is also 1/6. And anytime that you do copy, change, flip, when you do the multiplication answer, it'll be the same for the division answer. Now, this is only one that we have with just plain numbers. Let me break this down a little further for you. Let me do one that has some variables. We'll do a simpler one and then a more complex one. So the simpler one would be 15n cubed, 16n squared, 9n to the fifth, 10. So this guy, finally we got some letters. But notice it's a division symbol. So your first step is going to be copy, change, flip. Copy the first one just the way you see it. Change this to a multiplication symbol. Flip this fraction. Always flip the one after the division, the one that you're dividing by, your dividend. Now that you have the four corners, we can start factoring them out because we have multiplication. So since they're all monomials, we're going to do a tree diagram. 15 we can do in our head, that's 3 times 5. And then that's just the number. Remember to break down the variable part. Don't keep it in in exponential format. Put it in factored form. So m cubed, get rid of the cubed and write out the m 3 times. Because remember, this 3 only applies to the base of m. Does not apply to the 15. Remember how we talked about exponents? It can only apply to the one item that's directly in front of it. So even though there's a 1, a 5, and an m, it can only apply to the m. So there's 3 m's. Break down 16n squared. 16, in your head you can do 4 and 4. And 4s can break it down as 2 and 2. So it's 2, 2, 2, 2. N squared, n, n. Remember, the 2 only applies to the n, not to the 16. Third corner, 10, you can break down as 2 times 5. And then since this does not have an exponent, it's understood that there's only one n. And then break down 9, we know it's 3 and 3. And then n to the fifth, 1, 2, 3, 4, 5, and they're all multiplied. Now that you've broken down each of the corners, remember that big super fraction bar that we were doing was the multiplication, guys? And then seeing anything on top that cancels anything on the bottom. So we know that a 3 and a 3. And an m and an m. Another m, another m. M, m. Let's look. 2 and a 2. N and an n. We got a lot of things that are left over. That's fine. We have a 5 and a 5 and all these 2's and this 3 and then these m's. So we can break this down and we say on top 5 and 5, whatever's left over, when they're monomials, I will multiply. When there were binomials left over, I left them as factors. Because what looks cleaner? 2, 2, 2, 3, m, m. That doesn't really look clean. When they're monomials, multiply them out. So 5 times 5, 25. 2 times 2 times 2 is 8, times 3 is 24. 1, 2 n's, and an n. I forgot that e's still left over. So make sure you write it as m squared n. Now some people might be asking, why did you put the m squared in front of the n that was left over? Because you always want to put this in alphabetical order. And so we had all these 2's, almost forgot the n, caught it at the end, m's and the 3. So all these make up this here, this here. So here we have our reduced answer. And then let's do one more of these. Before we get to sample questions. We did one that has monomials, so of course you know I'm going to pick out one that has binomials and trinomials. So how do we work on this guy? Well, let's bring in our rules. So now that we have our traditional dividing rational expression, 7.2 for dividing, the first step is to copy, change, flip. If you forgot, copy is the first fraction just the way it is. The second, change the multiplication of the sign to division. And 3, flip, or just get the reciprocal of the second fraction. Once you do that, then we're just following the steps for multiplication. And the condensed version is factor the four corners completely, draw one big superfraction bar, and then cancel out the matching factors. Whatever the leftovers are will be your simplified answer. If they're monomials that are left over, I suggest to multiply. If it's binomials left over, leave them. So let's do that. Copy, change, flip first. Alright, so just copy. You know you're going to change, and then you're going to flip. Flip, you can see top goes to the bottom and vice versa. Now that I have a multiplication symbol, now I can do my four corners. Factor out the top corner. Look for a GCF. I can tell you there is no GCF because no matching parentheses, no letter, no number, no negative. So I started off with 2 sets of parentheses. Why? Because 2 terms is difference of squares, minus sign, check. Perfect square, check. So I can do this as difference of squares. 1 plus, 1 minus. Break down v squared as v and v. Break down 9 as 3 and 3. Next corner. Notice no GCF. Ladder, ladder, no ladder. Number, number, no number. Doesn't start with a negative, and of course there's no matching parentheses. But I have 3 terms here. So unlike here, where I had to do difference of squares, this 3 guy, because it has no leading coefficient, we're going to do shortcut. Shortcut, remember, is those 6 steps. Setup, sign, so plus means that these are the same signs. So you gotta look at the middle to determine what type. 2 positives, so that's step 2. Step 3, do all the combos of 6. 6 is 1 and 6, 2 and 3. Fourth step, we know we have to add our list. Fifth step, choose a combo. 5, 5, so we choose. And then placement, because these are both the same signs, step 6 says it doesn't matter where you put the 2 and the 3. Third corner, GCF, yes. Not that they have the same letters, not that they have matching parentheses, not that it starts as a negative, but they both have the same number, because remember 8 is 2 times 2 times 2, so we can take out a 2. So then you're left with v plus 4. And then you can see here, what's left over is 2 terms. 2 terms you want to check to see if you can do difference of squares, and you can't. With a plus sign, it's out of the question. And then the last corner. Again, look for GCF. I can tell you, no matching parentheses, this doesn't have a letter, these don't have numbers, doesn't start with a negative, so no GCF. But because it's 3 terms and it has no leading, we're going to do shortcut again. So 2 sets of parentheses, write down v squared as v and v, that's step 1. Sign issue, minus sign, 1 plus, 1 minus, that's step 2. Step 3, do all the combos of 12. 12 is 1 and 12, 2 and 6, 3 and 4. Once we do that, then we're going to have to add, subtract. And then we're going to choose a combo. Right? Now some of you might have a hard time choosing a combo for this guy because we have numbers, and notice there's no number here. If your middle term doesn't have a number, we always told you there's an understood coefficient of 1. So 1, 1, we do have a match. So we chose our combo, that was our step 5, and then step 6, placement. Now remember, because they're different signs, it's a little tricky. Take the bigger number, 4, it's going to get the same sign as the middle. The middle is positive, so the 4 gets the positive, the 3 will get the negative. Now that you're done factoring each of the 4 corners, then we told you draw your one big super fraction bar, and then start canceling out. And cancel out the matching parentheses first, the binomials. So notice we have a w plus 3, w plus 3. Notice the v plus 3 and a v plus 3. And here a v minus 3 and a v minus 3. And then here v plus 4 and a v plus 4. So what's left over is these two guys. Now notice this is a 2. Notice this has a 2, but it's stuck as a binomial. So our answer is this. And if you want to use parentheses, that's fine. So we showed you one was fractions, we showed you one that were monomials, and now here we have one that has binomials and trinomials.